Hey everyone, and welcome to this EA Power Technical Explainer. Today, we're going to walk through connecting an automated fuel filling system to your generator set. This is absolutely key for ensuring you've got that uninterrupted power when you need it most.
All right, let's jump right in. We'll be focusing on the EA Power EAC 1100S diesel generator and its brain, the DSE 7320 controller. Getting this set up right is what makes continuous, reliable, and totally unmanned operation possible. So before we grab any tools, let's just take a step back and look at the big picture. Understanding how all these pieces fit together is going to make the actual wiring process a whole lot smoother.
Okay, so here's the complete journey our fuel takes. It starts in the main storage tank and needs to get to the generator's daily tank. The pump, well, that provides the push, and the solenoid valve acts like a super responsive gate, snapping shut to prevent any leaks or siphoning when it's off. And the maestro conducting this whole orchestra? That's our DSE 7320 controller.
Now, before you touch a single wire, let's talk about something that's non-negotiable for safety and performance. Your cable. You've got to use 2.5 square millimeter cable. That goes for both the 24-volt battery connections and the feed to the electric motor. It's designed to handle the load safely. So with the right cable in hand, we are ready to go.
Let's head over to the control panel itself and get the core logic configured. This is the step that really empowers the DSE controller to manage the fuel transfer all on its own, making the whole system truly automatic.
And here's something you're going to love about this design. See that X6 terminal group? Everything we need for control wiring is centralized right there. This just makes the installation so much cleaner, and believe me, if you ever have to troubleshoot down the road, you'll be glad it's all in one place. Okay, this first step couldn't be simpler, but it is absolutely vital. Find terminals 136 and 212 on that X6 group. Once you've got them, just bridge them together with a secure link. What this little jump does is keep the control relay permanently energized, which is what lets the DSE controller work its magic and manage the fuel logic internally.
Perfect. With the control logic enabled, we can now connect the muscle of the system, the pump and the valve that are actually going to move that fuel from the main tank over to the daily tank.
All right, pay very close attention here, because we're working with two different kinds of power. On one hand, you've got the AC fuel pump running on 230 volts. On the other, the DC fuel valve, which operates on 24 volts. You absolutely do not want to mix these two up.
Getting these connections spot on is everything. So for that 230-volt AC pump, your phase wire goes to terminal 3/6, and the neutral lands on 4/9. Easy enough. For the 24-volt DC solenoid valve, you're connecting to terminals 5/36 and 6/19. And remember, with DC, polarity is king. Get it backwards, and you could easily damage the valve's coil.
Okay, time for our final electrical connection, and it's a big one, the fuel level sensor. This is what gives the controller the eyes and ears it needs to know exactly when to start and stop that pump.
Now, this is a question I hear all the time. People look at the board and think, hang on, we just put a bridge on terminals 136 and 212 for the control logic, so where in the world does the fuel sensor go? And you know what? It's a perfectly logical question. And this slide shows the brilliant answer. The DSE controller was designed with exactly this in mind. The fuel level sensor has its own dedicated input on a completely separate terminal group. So that bridge we made, no conflict whatsoever.
So let's be absolutely crystal clear on this. Your analog fuel sensor connects to pin 17 on the controller. You get to that pin through terminal 2434, which, as you can see, is on the X3 group. The bridge is on X6, the sensor is on X3. They are two completely different circuits.
And just like that, the wiring is done. Your system is now fully connected. But hold on, we're not quite finished. Let's go through the final checks to make sure this installation is safe, secure, and built to last.
All right, let's run through our final reliability checklist. First, go to every cable gland, the fittings where the cables enter the panel, and make sure they are properly tightened. That gives you strain relief and keeps moisture out. Second, double-check that bridge between 136 and 212. Make sure it's secure. And finally, give the pump and valve connections a gentle tug. You want them to feel nice and firm. Trust me, these simple checks prevent those annoying intermittent faults and keep your system running like a dream.
This really brings us to the whole point of this exercise. A secure connection today prevents a fuel-starved generator tomorrow. A really meticulous installation, it's not just about neatness, it's the very foundation of a reliable power system.
So, there you have it. Your automated fuel system is officially online. And once you've automated something this critical, it really gets you thinking, doesn't it? What's the next efficiency you can engineer into your setup? What other process can you improve to boost your system's overall performance?